Welcome to Learn and Practice Video Tutorials. This is the 8th video in the database series, covers the advanced queries with multiple tables, more on and/or, calculations and summary queries. Disclaimer. This video is aimed at CAT learners who need to keep up with school work during COVID-19 crisis. It is not as polished as I would like it to be, nor is the sound great. Perhaps if it is found to be useful I will improve it in the future. Tips for using. Do it with the video, pause when you need to, slow it down or speed it up with the playback speed. See tips for using videos for lessons.mp4. Create a query named props which shows name and surname of only the props, in surname order. It is very similar to surname order in previous video, but with two differences. One, we only want the props, and we do not need to display the position. Click Create. Click Query Design. Click Rugby to add the table. Click Add. Click Close. Double-click Name. Double-click Surname. Now, although we do not want to display position, we do need it in the query in order to restrict the rows to only the props. Double-click Position. We use the criteria to specify which records we want to see. Here we only want to see the rugby players who have prop as their position. So click under Position, in the criteria row. Type prop. Click Data Sheet View. This error message says you asking for a string but it has a integer. Or in other words, you giving it text but it has a number in this field. Remember when we created the lookup wizard and linked the position field to the position list table? I told you then that Access actually stores the ID value, which is the primary key from the position list table in the rugby table. Click the OK button. Two choices how to deal with this. Go find the ID value for prop. Or add the position field from the position list table. The first option, you simply put the value 8 here. The second option, we need to add another table to this query. Click Show Table. Click the position list. Click Add to add the table. Note that the relationship between the two tables are shown. Double-click Position to add the field. Click in the criteria under Position from the position list table. Type prop. Click Data Sheet View. So we can see that we have the correct records. But we are not finished yet. Let's go back to Design View to do the last step. The question said only to show name and surname. To hide the position field, take the tick away in the show row. But strictly speaking, we do not need the position field from the rugby table. Click the gray area at the top of the field. So it highlights it. And then press the delete key. Click Data Sheet View. Save the query with required name. Click Save. Type props. Click OK. So let's do a quick recap. In the props query we learned what happens when we use a lookup wizard as the data type. We added a second table to a query, we added the field from that table, we included a criteria, we hid a field and we deleted a field. Well done. Create a query based on the rugby table which will show the name, surname, height, and weight for all those players who have a weight in the range 100 and 125, including 100 and 125, or a height that is less than 1,8 meters. By now you know how to create a query. But I include the steps for completeness sake. The question told us to base it on the rugby table. I tend to use the double click to add fields because I find it quicker. You can of course click and drag. Or you can use the down arrow button. Once you have all the required fields name, surname, weight, and height, we are ready to start with the criteria. Oh, we need a quick maths lesson. Arrange. With square brackets. The square brackets are drawn as colored in circles on the number line. And means that, the number is included in the range. So a variable in this range can be 100, but it cannot be 99. It can be 112 and 124 and 125, but not 126. So when we do criteria, we use the AND operator. So the weight can be greater than 99, or we can say it can be greater than and equal to 100. And at the same time it must be less than 126, or we can say less than and equal to 125. So when you do the criteria, remember to put the equals in or to change the number. Click in the criteria under weight, type greater than 99 and less than 126. Let's go look at the results. Click Data Sheet View. Don't assume you have done it correctly, get into the habit of checking the results. Are there any values under weight that are out of the required range? It is not foolproof but does help. Let's go back to Design View. The second part of the criteria is the or a height of less than 1,8 meters. So even if his weight does not fit into that range, if he is less than 1,8, his record must appear. Click in the or row below height. Type less than 1,8. Click Data Sheet View. Check the data. Colby has a weight outside the required range, but he has a height of 1,71. Yanchis and de Klerk are the same. Click Save. Type query 10. Click OK. Click the Query 10x button to close it. In the Query 10 we used an AND operator to create a range as the criteria. We also use the OR criteria row. That's great. Create a query based on the player stats table, show the name, surname, against and wins for the players that played against either the Argentina or Australia and they have had more than 5 wins. Click Create. Click Query Design. Ensure player stats selected, if not click it, and then click Add. Click Close. Add the required fields, surname, and first name. The against field. Click and drag, or I used the scroll wheel of my mouse. Find W and double click on it. The first part of the criteria, which team the played against, is different values in the same field. So the record cannot have 2 values at once, it is either Argentina or Australia but never both. So we want an or in the against field. There are 2 ways of doing this. We will look at both. The first method is to use only the criteria row and the or operator. Type Argentina or Australia. Let's look at the results. We can see that only Argentina and Australia are in the results. The wins have numbers from 0 to 12 in the results. So we need to do the second part of the criteria. The second part of the criteria is that in both cases the win must be greater than 5. Using the same criteria row means N. Click in the criteria row under W. Type greater than 5. Let's check the results. So only Argentina and Australia that have wins of greater than 5. How up? Click Save. Type 5 wins. There is another way to do the criteria. So let's go back to Design View. Delete or Australia. Type Australia in the or row. You don't need the word or. But if the criteria are in different rows, you have to put the greater than 5 in both rows. Otherwise you are saying if it is Argentina the wins must be greater than 5, but if it is Australia the wins can be anything. Type greater than 5. Check the results. Same results. In the 5 wins query we learned that the AND criteria must be repeated if you use the OR row. Next query, create a query based on the rugby table, call it October, to find out if there are any players with a birthday in October. No, we cannot use wildcards. Let's get started. You can start from scratch by clicking Query Design, or you could copy question. If you starting from scratch like me, add the rugby table. And close. Add the field's name, surname, and birthday. We will use a calculation in order to extract the month. Click in the next empty field. Right-click in the empty field. Click Build. Click Functions. Functions are existing calculations. Click Built-in Functions. These functions are similar to the ones in Excel. Here are the different categories. They help make finding the function easier. Here are the functions in the selected category. Click Date Time. The date returns or gives you today's date. Over here you will see a description of the selected function. But warning, the language is sometimes hard to understand. Click and drag down until you can see the month function. Click Month. Here you can see the description. Hope you get that it says it will return the month as a number between 1 and 12. This area is where you will create the calculation. Double-click Month. The name of the function. The things between the triangular brackets is a placeholder. We need to replace it with a date value. Click and drag to select the placeholder including the triangular brackets. We want to replace the placeholder with the birthday field from the rugby table. Click the plus button in front of the name of your database. It has a CCDB behind it. Or you can double-click the database. Click Tables. Click the table you want, in this case rugby. The fields of the table appear here. Double-click the birthday field. The full name of the field is inserted into the field. Note that the table name and the field name are each enclosed in square brackets, and the table name is separated from the field name with an exclamation mark. Click OK. The calculation has been inserted into the field. Everything before the colon is the heading of the field. We want something meaningful here. Click and drag to select Expire 1. Type month. Let's go see what the results look like. Click Data Sheet View. See the integers, which is the month of the birthday date. And see the heading of the field is month. Now let's go filter the records. Click in the criteria under month. Type 10. Let's go see if it has worked. Click Data Sheet View. Oh goody, it worked. Click Design View and let's hide month. To hide month, take away the tick in Show. Click Save. Type October. Click OK. In October we learned how to use the build option. We learned how to find the built-in functions, specifically the month function. We then learned how to add in fields from the tables. We discovered how to label the calculation field and use a criteria in it. Great job! Create a query based on the rugby table. Show the name, surname, and the age of the player this year. This is another calculation query. Click Create. Click Query Design. Add the rugby table and click Add. And close. Add the fields, name, surname. Right-click the next free field. Click Build. There are many ways to calculate age. One method is to subtract the birthday from today's date. In Access we have function date, which returns today's date, and a function called dateDiff which subtracts two dates. Click Functions. Click Built-in Functions. Click Date Time. Double-click dateDiff. The function gets inserted, with the placeholders. So anything between the double angular brackets need to be replaced. The dateDiff function has 5 arguments. The first one is the time interval to be used, like for Ys, which is for year, M for month, or D for day. Then you have the 2 dates, and the next 2 are optional. If you don't have the first day, it assumes Sunday is the first day, and the last one will assume the first week is the one with the January 1st. Select date 1, including the angular bracket. Double-click date, to insert the function for today's date. Click and drag to select date 2, including the angular brackets. Click your database name. Double-click tables to open them. Or you can click the plus button in front of the tables. Double-click rugby to open the table. Double-click birthday, to insert it. Replace interval with YYYY. Select the last two arguments and press delete. We will use the default options. Make sure you delete the comma too. Click OK. Click in the field to unselect it. Click and drag to select Expire 1. Replace Expire with age. So the heading of the column will be age. Let's look at the results. The heading is right. But oh no, the values are negative. This means the two date values are the wrong way round. Let's go edit the expression. Right-click. We will go back to build. You can either go back and re-watch the steps to redo them in the correct order, or you can copy and paste and put them in the correct order. Once you have redone it, click OK. Click Save. Type age. Click OK. Let's go look at the results. That's better. In the age query we learned how to calculate the age given their birth date. So we used the build again. Using the built-in functions date and dateDiff. We also learned how to edit an existing calculation. Great job! You can create summary queries which can calculate values like totals, averages, count, across the records for fields. Create a query to show the how many countries played against, the total of games played, the average of tries and their highest points scored, per player. Call it total. Click Create. Click Query Design. Player stats must be selected, then click Add. Click Close. Add the fields that are required: surname, first name, against, PLD. Double-click Try, and PTS. A totals query allows you to group records together, and then calculate things like totals and averages across records. Not just for one record. To change to a totals query, click the summation sign. A new row has been added to the query design view. The fields in the query must have a value in this total row. So it either has to have a calculation or be grouped by. So we want one row for each player. The surname and first name combine to identify the player, so we will group by them. The rest will have the calculations. The first one we will change is against. Click the down arrow. We need a field so that we can see how many records there are per player. So we will use against. Click Count. We want the total of the games played. So click under PLD. Click the down arrow under PLD. Like in Excel, sum means to add up, or total. So click Sum. We want the average tries. Click Average. The average is likely to have many decimal places. But let us restrict it to 2 decimals. We do this in the property sheet. If you do not have the property sheet, you can open it here. Click Format. Click down arrow. Click Fixed. Click Decimal Places. Click down arrow. Let's make it 2 decimal places. We want the largest number of points for the player. Click under PTS. Let's go see what it looks like. Click Data Sheet View. One record for each player. The number of records in the table. Not the query, and the total of the games played, the average tries, which is 2 decimal places, and then the largest points. Good, let's save. Type totals. In the totals query we learned how to create a totals or summation queries. These queries group records together and you can calculate a total of a group, how many records in a group, the largest number in a group, and the average of the group. You need to do the tasks, and past paper questions. The more examples you can do, the better, as each one will present a different problem. If you have found this video helpful, please like it and subscribe to my channel. Or leave a positive comment in Google Classroom, smiley face.